friends, welcome to my channel Selected Topics in Physics. Today I will show you the representation of Ohm's law using LabVIEW. So let's start. So as we all know, the Ohm's law can be written as V equal to I R. So let's make the font size bigger. (36). Okay. So this is the V equal to IR, where V is the applied voltage, R is the resistance, and I is the current. So if we calculate I, that is equal to V divided by R. So to know the current, we have to divide it the applied voltage with the resistance. So in a metal at a particular temperature, resistance value is fixed. V that we will vary in a systematic way, and we will measure current I. Then we will plot IV. That I will show using LabVIEW. Okay, so let's start. So I will go to the block diagram. Let's go to the block diagram. Okay, here I will show. First I will choose structure because I need to vary something. So let's use a for loop. Now this is broken because the circuit stop pillars are there because circuit is not completed. Okay, so now I have to use one numeric that I'll use add. So here I will vary the voltage. So I have to increase. So if you want to use in a decrement way, then you have to use this palette different way. That is minus you have to use. Okay, so here I will use plus. So here first one is the you have to create one control so that I can vary the voltage value from the front panel, and this another terminal I will connect with this I. So this I will vary from 0 to 1, then 2, 3 in a systematic way in steps of 1, and this n I make as control. Okay. So for example, if I will give n equal to 10, so it will start from I equal to 0 till 9, total 10 values. Okay, so this is the voltage part that is okay. Now I have to use a okay. So V equal to IR. So this is the V, and I we will calculate, and R we have to use. So let's use another numeric palette. So that will divide. So this will paste here. So this is the equation I equal to V divided by R. So this is V, and R we will set, and so V and then divide by R. So that we will create as a control. Okay. So this is the R. That means this Y is the R. So that we will write as resistance. Okay. And numeric is the number of points, and this X is the voltage. Okay, so these three are the input value, that is the voltage, numeric or number of points, how many data points we need, and this is the resistance value, what is the resistance value. Okay, so now this is the indicator, that means the output. So create indicator. So this is the output. So this is the X divided by Y. This is the current. Okay, let's change it to current. Okay, this is the current. CURN. Okay, this is the current. It is not showing because this is smaller, let's make it bigger. Okay, this is the current. Fine. So now I will show you uh, in a graphical way. So let's make this size bigger. Okay, and now I will go to the front panel. This is the front panel. Okay, so here after right click, you go to graph, and this is the okay. Okay, this is graph. So this is the graph. This time I will show the voltage, and this is the current. Unit you can set accordingly. For example, by default it will be voltage, and this is ampere. So make it in the for loop so that we can see the actual change while the loop parameters will vary. So this is the x input will be the voltage. So our voltage is this part, and y, this is the this part, this is the current. Okay, so in the x axis voltage and y axis is the current. So one more thing, we have to check the reset, we have to make it constant, then make it false, so that this data point we can see. Okay, I have to make it false. Now it is correct. Okay, so to understand better, let's give some time delay. So going to time and then give it time. So here I am giving create something like that. You can make it control. For example, if you want to use 100 millisecond interval data acquisition or 1 minute data acquisition, that depends on you. So I am giving a constant and make it 1000. So this is in millisecond, that means it is 1 second. Okay, so it is connected. So now everything is ready. So this I will vary from 0, then 1, 2, like that. Numeric that we will give from the front panel, and this is the starting voltage, and resistance value we have to give so that we can calculate the current. Okay, and in the graph we can see the actual representation. So this plot will make it a nice way like that dot. So each white and black spot will show the data point. So you can make it larger, and to current unit you can give it ampere, and voltage you can give it voltage. Okay, now it is fine. So let's give voltage equal to V equal to let's say 10, and number of points you need to, for example 20, and resistance if you can give maybe 100 ohm. Okay, so this is the current, and accordingly it will show the uh, representation how the voltage varies and current is varying. So here it is showing list of error. What is the list of this? Error is not connected to anything, so error. Okay, okay, so this is the error, so I have to delete it. Okay, now there is no error. Okay, now I am going to the front panel, and let's run the program. Okay, so this is the first point, second point. So as you see, voltage is varying from voltage 10, and it is increasing to a particular order. That means I equal to 0, that is first point is 10, then 11, 12, like that. So it will go it will total 20 numbers it will calculate. So if you calculate, the total numbers are 20. So if you start from 0, and if you need 20 points, so it will start from 0, then 1, 2, like that. So let's see how it works. So 0, then 1, 2, 3, like that. So total 20 numbers. So as it is a metal, so this IV curve is a linear one, and here also we are seeing the linear behavior because we have used V equal to IR, this relation, that is the Ohm's law. And to make it more general program, you have to change here so that you can use in a systematic way, you can use you can vary the step size. Here the step size is by default 1, because I have used here I I, so that it will vary from I equal to 0 then 1 in a systematic way. So if you want to use a systematic way in another step size, for example 0.5 volt or 0.2 volt, then you have to make some numerical calculation here, and then you have to add it in this voltage, this part. So then after adding this, you have to divide with this, then only you will get this your general step size value or a customized step size. Okay, so that you will try, and if you face any problem, let me know in the comments. So thank you for watching.